Hello guys, welcome to Statistics Bio 7. I'm Dr. Mohan Arthanari. This channel fully focuses on the biostatistics data analysis and data visualization related video post on this channel. If you like the channel video, click to the subscription button and support to me, join to our channel membership. Let's go to the video. Now we are the discussion topic, interpretation of quadratic discriminant analysis. What is the quadratic discriminant analysis and how to analyze the quadratic discriminant analysis QDA in RStudio? That video already published in our channel. That video link mentioned also this video description box. And the full code for the quadratic discriminant analysis in RStudio, the full code article published in our website. That link also mentioned for this video description box. Okay, now the interpret for the quadratic discriminant analysis in RStudio, analyze the data. Okay, the introduction for the QDA. The QDA is a supervised classification technique used to distinguish groups based on predictor variables by modeling class specific covariance structures. Unlike linear discriminant analysis LDA, QDA allow for non-linear discussions boundaries, making it more flexible for the dataset where variations differ across the groups. In this study, QDA was applied to classify the specific based on key environmental factors, including temperature, pH, and salinity. To understand their ecological distributions, the model's performance was evaluated and the results provide insights into the species environmental relationships, misclassification patterns, and potential ecological niche overlap. The table 1, group mean for environmental variable across the species. The species A to J, the temperature unit for the degree, and the pH salinity unit for the ppt. So the interpretation of the table 1, the species A and species G are associated with the lowest temperature and salinity levels, indicating the performance for the color and low salinity environments. The species J and species F expected the highest temperature and salinity value, suggesting the adaptations to warm high salinity habits. The species G and I occupy an intermediate range, but they tend toward the higher temperature and salinity. The pH value range between 5.78 species G to 8.79 species J, indicating the species specific to tolerance to the pH variations. The table 2 for the QDA classifications result species A and species J. The species A, then species A5, and the species F2, species C is a 1, species H and species B is a 1 value. The interpretation of the table 2, the model correctly classified the 90% of species within the 45 to 50 samples correctly identified. The misclassifications of the table 2, the species C was misclassified as a species F and species I, the possibly due to the overlapping environmental conditions. The species F was misclassified as a species C and species J, the indicating similarly the environmental niche. Species H was misclassified as a species B, suggest the more shared characteristic in their environment. The other species for the A, B, D, E, G, I and J were 100% correctly classified, indicating the strong separately. The graph for the QDA classifications, the species clustering along the environmental gradients. The species exhibited a distinct gradient along the temperature and salinity axis, with sample with some species occupying the low temperature, low salinity ranges, example species A and G, while other are found in higher temperature and salinity conditions. Example for species J and F. This suggests that the temperature and salinity play a significant role in species distributions. The classifications accuracy and misclassifications patterns. The QDA models achieved 90% of accuracy, indicating the strong classification performance. Some species, example for the species C, F and H, exhibited overlapping regions leading to the minor misclassifications. For instance, the species C, triangle, and species F, the brown, appear the close in future space, suggesting the shared environmental performance. The misclassified point and ecological implications. The misclassified point examples inside where actual and predictor species trap may indicate the environmental needs overlap or variability in the species tolerance to abiotic factors. Further inclusive of additional ecological variables, example the dissolved oxygen's nutrient level, may engage the classification's precision. The ecological significance. The models provide the insights into the species environmental interactions, essential for the habit conservation and biodiversity monitoring. The clustering of the species along the environmental gradient in highlighting the potential climatic include the shifts in the species distributions under the changing environmental conditions. The conclusions for the QDA. The QDA effectively classified the species based on environmental variable such as the temperature, pH and salinity, achieving a high accuracy of 90%. The model captures non-linear relationship and group-specific covariance structures, demonstrating its suitability for the ecological classification text. The misclassifications patterns indicated the some overlap in environmental performance among the certain species. The highlighting the complexity of ecological interactions. The QDA results provide the valuable insights of the species distributions modeling and ecological monitoring, supporting data drive the conservations and management strategies. The further studies incorporating additional environmental parameters may engage the classification performance and ecological understanding. Okay, if you any doubt on this interpretation of quadratic discriminant analysis in RStudio, leave me comments in the comment box. I will reply to you. And if you like this channel video, click to the subscription button. Thank you for watching this video.